The process begins by creating ICF blocks using the Lego principle, which involves interlocking blocks without the need for additional reinforcement. These blocks are made from expanded polystyrene EPS foam and are designed to fit together like a giant puzzle. While the Lego-style ICF blocks offer structural strength, reinforcing the walls is essential for added durability. Uniform insulation throughout the construction is vital for energy efficiency. The ICF system inherently provides continuous insulation along the entire surface of the walls. To enhance energy efficiency further, it's essential to minimize thermal bridges. Thermal bridges are areas where heat can escape more easily. ICF blocks are notably lightweight, with an approximate weight of 2.5 kilograms per block. Optimal team size of 2 to 3 people in ICF house construction offers several advantages. This compact team can efficiently collaborate to assemble the ICF blocks with precision and speed. Each team member can focus on specific tasks, such as block placement, reinforcing, and alignment, ensuring that the construction process proceeds smoothly. With fewer team members, communication is streamlined and decision-making becomes more efficient, leading to a faster and more accurate construction timeline. Prefabricated window and door frame elements are integrated into the ICF walls. This step not only speeds up the construction process, but also ensures proper alignment and sealing, contributing to energy efficiency. The culmination of the 3-week process results in well-insulated, monolithic concrete foundations and walls. In the realm of infrastructure development, the Cullera-Favara variant bridge emerges as a pivotal project poised to revolutionize transportation in the Sueca region of Spain. This ambitious endeavor not only promises to alleviate traffic congestion, but also tackles the perilous road conditions that have plagued the route between Cullera and Favara for years. With a comprehensive length of 8,620 meters, this innovative bridge is designed to facilitate a seamless connection between the two towns, rendering travel safer, faster, and more efficient. This article delves into the significance of the Cullera-Favara variant bridge, its potential impact on the region's transportation landscape, and the specifications that underscore its engineering excellence. The foremost objective of the Cullera-Favara variant bridge is to enhance the safety of commuters traversing the critical stretch between Cullera and Favara. Currently, the N332 road, winding through the municipality of Ribera Baixa, grapples with heavy traffic, posing risks to both drivers and pedestrians. Moreover, the straight road that links Cullera and Favara has garnered notoriety for its frequent accidents, some of which have proven fatal. With these concerns in mind, the Ministry of Development initiated the bridge project, foreseeing a future where such tragedies are minimized, if not entirely eradicated. Statistics underscore the urgency of this intervention. An estimated 18,000 vehicles navigate through this passage regularly, with a staggering 12.75% comprising heavy vehicles. This heavy traffic places immense strain on the existing infrastructure, contributing to congestion and elevating accident risks. By introducing the Cullera-Favara variant bridge, authorities aim to disperse this traffic more effectively, redistributing the load and reducing the chances of accidents. The proposed bridge not only reshapes transportation patterns, but also safeguards lives and livelihoods. The heart of the Cullera-Favara variant bridge lies in its capacity to bridge the existing gap between the towns of Cullera and Favara. This connection holds considerable promise for economic growth, as it streamlines the movement of goods, services, and people. The bridge is not a mere piece of infrastructure, it is a conduit for progress, creating opportunities for businesses to flourish and local economies to thrive. With a length spanning 8,620 meters, the bridge transcends physical barriers, fostering an environment where collaboration and prosperity can flourish. The engineering brilliance underlying the Cullera-Favara variant bridge cannot be understated. The bridge is envisioned as a two-lane highway, complete with 2 lanes on each side, measuring 3.50 meters each. These generous lanes accommodate the demands of modern traffic while allowing for a comfortable driving experience. However, the project's foresight extends beyond the lanes themselves. The bridge boasts inner shoulders measuring 1.50 meters, serving as safe havens for vehicles in distress or emergencies. Moreover, the outer shoulders span an impressive 2.50 meters, further enhancing the safety quotient. These provisions, alongside the meticulously designed lanes, collectively work to mitigate potential risks and offer travelers a secure journey. Beyond its commitment to safety and connectivity, the Cullera-Favara variant bridge also addresses the need for efficient transportation. Designed for a minimum speed of 100 kilometers per hour, the bridge redefines the pace at which journeys between the towns can be undertaken. This consideration is a testament to the project's comprehensive approach. It not only enhances safety, but also optimizes travel time, aligning with the demands of modern life. The Cullera-Favara variant bridge stands as a testament to the transformative power of infrastructure development. By eliminating hazardous routes and streamlining connectivity between Cullera and Favara, the project endeavors to redefine transportation in the region. The statistics on traffic volume and the history of accidents underscore the urgency of this intervention. The bridge isn't just a physical structure, it embodies the aspirations of a safer, more connected, and economically vibrant community. As the engineering marvel takes shape, with its 2 lanes on each side, generous shoulders, and a focus on speed, it paves the way for a future where journeys are characterized by safety, efficiency, and progress. The Cullera-Favara variant bridge, poised against the picturesque Spanish backdrop, represents a bridge to a brighter tomorrow.
The Riyadh Underground's Orange Line has witnessed a remarkable feat of engineering with the introduction of the monumental tunnel boring machine, TBM, named Jazla. This event unfolded on a significant day in July 2015 when Prince Faisal bin Bunder, the governor of Riyadh, proudly inaugurated the colossal TBM for its role in shaping the Orange Line of the Riyadh Metro. The construction of this line is overseen by the Riyadh New Mobility Consortium, ANM, with Salini Impregilo at the helm, steering the direction of the 41.2 kilometers Orange Line, which stands as the longest stretch of the Riyadh Metro project. Jazla, a true engineering marvel, stands an impressive 10 meters in diameter and carries a weight of approximately 700 tons. It embarked on its monumental task of tunneling beneath the bustling streets of downtown Riyadh, setting in motion a groundbreaking initiative that would pave the way for modern urban mobility. This gigantic TBM began its journey by boring through a 5.8-kilometer tunnel that would span through the very heart of Riyadh, making a significant mark on the city's infrastructure. One of the Orange Line's standout features is its trajectory, which includes a passage through the iconic Riyadh main train station. This strategic routing not only enhances the accessibility of the metro, but also underscores the intricate planning and execution of the project. As the TBM Jazla continues to forge its path through the depths of Riyadh, it leaves an indelible imprint on the landscape, marking a significant step towards transforming the city's transportation system. The magnitude of the Orange Line project, led by Salini Impregilo, is underscored by the sheer scale of the TBM Jazla. With its colossal dimensions and remarkable capabilities, Jazla embodies the spirit of innovation and determination that characterizes the Riyadh Metro venture. As the TBM advances, it signifies a leap forward in enhancing the city's mobility, reducing congestion, and laying the foundation for a more connected urban future.
Rickmansworth, a picturesque town nestled in Hertfordshire, United Kingdom, boasts a historical landmark that not only connects the town physically, but also bridges the gap between the past and the present. the Rickmansworth Met Rail Bridge MR88. This iconic bridge, which was replaced over the Easter weekend of March 2014, carries with it a rich history and cultural significance that is as compelling as its engineering marvel. Dating back to the late 19th century, the MR88 bridge stands as a testament to the ambition of the Metropolitan Railway's expansion plans. During a time when the railway was the lifeblood of transportation, linking London with its suburbs was a monumental undertaking. The bridge was not just a means of crossing, but a symbol of progress and connectivity, a sentiment that still holds true today. The replacement of the Mr. 88 bridge in 2014 was not merely an engineering feat. It was a meticulous process that required careful planning, collaboration, and execution. The project was awarded to Barhale, a construction company that took on the responsibility of replacing the aging structure. The challenges were significant. The bridge had to withstand horizontal and vertical loads, and the capacity of the old deck had to be upgraded. Barhale's success in not only completing the replacement on time, but also mitigating third-party delays, demonstrates their commitment to delivering on their promises. Throughout the project, Barhale's collaboration with the client underscored their dedication to both engineering excellence and historical preservation. Design challenges were tackled with a hands-on spirit, ensuring that the new bridge not only met modern standards but also paid homage to the Victorian-era architecture that defined the original structure. This collaboration between engineering expertise and respect for heritage showcases the harmonious blend of innovation and tradition. The Mr. 88 Bridge, standing as a silent witness to the evolution of transportation, has been more than just a physical connection between 2 points. It has woven itself into the cultural fabric of the community. The juxtaposition of its sturdy iron framework against the backdrop of the charming town creates a visual spectacle that has captured the imagination of artists, photographers, and storytellers for generations. Its image has graced canvases, photographs, and even local tales, making it a true icon of Rickmansworth's identity. However, the bridge's role is not limited to aesthetics or historical nostalgia. It is a living piece of infrastructure that has adapted to the changing times, from the steam-powered locomotives that once crossed it to the electric trains that zip by today. The MR88 bridge has evolved alongside technology, maintaining its relevance while reminding us of the journey that brought us here. The maintenance and preservation of the Mr. 88 Bridge stand as a testament to the community's commitment to honoring its heritage. Restoration efforts have been ongoing, ensuring that the bridge remains not only a safe passage for commuters, but also a link to the past. Each time a train crosses the bridge, it echoes the footsteps of countless individuals who have traversed its expanse, creating a palpable connection between generations. As we navigate the complexities of a rapidly changing world, the MR88 Bridge stands as a beacon of the importance of preserving historical structures. Amid the urban sprawl and technological advancements, it serves as a reminder of a simpler time when the railway was a symbol of progress and innovation. Commuters who cross the bridge today do so not only to reach their destinations, but also to pay homage to the legacy of the railway system that shaped our history and continues to shape our future. The Rickmansworth Met Rail Bridge MR88 is far more than a mere railway crossing. It is a bridge that unites the past and the present, the historical and the modern, the functional and the aesthetic. Its replacement in 2014, undertaken with precision by Barhale, speaks to the commitment of the community to preserve its history while embracing progress. This bridge is a reminder that even as we move forward, our connection to our roots remains vital. As long as the MR88 bridge spans the gap between Rickmansworth and Moore Park, it will stand as a testament to the enduring significance of our railway heritage. The Pelješac Bridge, known as Pelješac Most in Croatian, stands as a remarkable infrastructure feat in the Dubrovnik-Neretva county of Croatia. This cable-stayed bridge is not only a testament to modern engineering prowess, but also a significant step towards enhancing the connectivity of the region. One of the key functions of the Pelješac Bridge is to establish an uninterrupted link between the southeastern Croatian semi-exclave and the main part of the country, effectively circumventing the need to traverse Bosnia and Herzegovina's short coastal section at Neum. By spanning the sea channel between Kamarna on the mainland and the Pelješac Peninsula, the bridge remains entirely within Croatian territory, eliminating the requirement for any border crossings with neighboring Bosnia and Herzegovina. One of the key functions of the Pelješac Bridge is to establish an uninterrupted link between the bridge's construction journey commenced on July 30, 2018. The process involved intricate engineering and coordination efforts, leading to the connection of the bridge on July 28, 2021. Subsequently, after further preparations, the bridge and its associated access roads officially opened for traffic on July 26, 2022. Notably, the Ston Bypass Road, designed to accommodate buses, heavy trucks, and vehicles carrying hazardous materials, was inaugurated on April 19, 2023, further enhancing the bridge's functionality. The bridge's characteristics are impressive and highlight its complexity. The original design, conceived in 2007, initially featured a main span of 568 meters. However, the final iteration deviated from this initial plan. The bridge materialized as a multi-span cable-stayed structure, stretching across a total length of 2,404 meters. This length encompasses 13 spans, 7 of which are cable-stayed. Among these, 5 spans measure 285 meters each, while 2 outer spans are 203.5 meters long. 2 towering pylons, rising 98 meters above sea level and 222 meters above the seabed, stand as prominent features of the bridge. These pylons flank a navigation channel measuring 200 meters in width and 55 meters in height. The ingenious design of the bridge is attributed to Slovenian engineer Marijan Pijpenbauer. Due to Bosnia and Herzegovina's coastal strip at Neum cutting off the southern Dalmatia region from the rest of Croatia, physical connection occurs only through Croatian waters. An agreement allowing passage through Neum was never ratified, leading to border checks for those traveling between the Dubrovnik exclave and mainland Croatia. Croatia's inclusion in the Schengen area in 2023 would intensify checks, causing 3 border checks for the journey: Croatian exit, Bosnian-Herzegovinian entry, and Croatian entry checks. The construction of the Cetina Bridge stands as a testament to modern engineering ingenuity, aiming to alleviate traffic congestion and enhance the scenic beauty of the Omis region. Commencing in 2019, this ambitious project has rapidly evolved, with recent progress bringing the 2 halves of the bridge a mere 20 centimeters apart, heralding the imminent completion of a crucial infrastructure element. The prime motivation behind the Cetina Bridge project is to provide much-needed relief to Omi city center by redirecting traffic away from residential areas and mitigating the notorious traffic jams that plague the region during the bustling summer and tourist seasons. The bridge is envisioned as a critical link between the Komorjak and Omis tunnels, soaring at an impressive height of 70 meters above the river Cetina. Spanning an impressive length of 216 meters, the Cetina Bridge is a true marvel of engineering, characterized by its elegant steel girder design. The utilization of a closed steel box structure ensures that the bridge seamlessly merges with its natural surroundings, with a varying cross-section that narrows from 6.50 meters at the extremities to 2.50 meters in the center. The bridge harmoniously integrates with the scenic backdrop of the Cetina Canyon, preserving the captivating views that define the region. The construction process has been a meticulous endeavor, marked by innovative strategies that enable efficient assembly while minimizing disruption to the surrounding environment. The bridge's steel components were skillfully fabricated and pre-assembled in segments within controlled workshops. Subsequently, these precision-crafted segments were transported to the construction site and meticulously connected within the confines of the Comorjak and Omis tunnels. This intricate assembly process culminated in a remarkable feat of engineering as the two halves of the bridge were brought together with a mere 20 centimeters gap, ready to be permanently fused into a singular structure. The forthcoming period of just over 10 days is expected to witness the bridge's seamless connection, signifying a momentous achievement for both the engineers involved and the region's residents. The project's significance extends beyond this bridge itself, as the entirety of the Stobrek-Duggy-Rat-Omis Fast Road project it is part of seeks to alleviate traffic congestion on the frequently traveled Split-Omis route, particularly during the bustling tourist season. However, the remarkable construction of the Cetina Bridge has not been without its challenges. The unique topography of Omis, nestled between the mainland and mountains at the mouth of the river Cetina, has presented a complex and demanding landscape for the project. Overcoming these geographical obstacles has required a harmonious blend of technical prowess and environmental sensitivity. As the construction of the Cetina Bridge nears its completion, it stands as a symbol of human achievement, seamlessly merging engineering excellence with the breathtaking natural landscape. The transformation from steel segments manufactured in controlled workshops to a majestic bridge spanning the picturesque river Cetina encapsulates the dedication, innovation, and collaborative effort that define monumental infrastructure projects. With the Cetina Bridge poised to enhance both transportation and the aesthetic appeal of Omis, its completion is a triumph that will be celebrated by residents and visitors alike.
The advancement of rail infrastructure has long been a testament to engineering prowess, and the Administrator of Rail Infrastructures, ADIF, of Spain exemplifies this through its strategic plans and accomplishments. Within the broader context of the 2006 to 2020 Infrastructure and Transportation Plan, ADIF undertook the monumental task of establishing an extensive rail network spanning 10,000 kilometers across Spain. A central element of this endeavor was the creation of a high-speed railway in the Levante region, stretching for 914 kilometers and requiring a substantial investment of 12.4 billion euros. This project stood out not only for its scope, but also for its technical challenges, including accommodating trains with a top speed of 350 kilometers per hour on curves with broad radii and gradients below 3%. Overcoming these obstacles while considering environmental conservation led to innovative solutions and distinctive projects along the rail line. A particularly extraordinary segment of this rail project is the CONTRERAS Reservoir Viar Gordo del Cabriel section. Characterized by the need to construct 3 tunnels and 3 viaducts, this section posed formidable challenges due to its rugged terrain and the imperative of preserving the Cabriel River Gorges Natural Park. This stretch traverses 2 provinces, Mingranilla in Cuenca and Viar Gordo del Cabriel in Valencia, running parallel to the A3 highway corridor. The responsibility for constructing the platform within this segment, extending from the CONTRERAS Reservoir to Viar Gordo del Cabriel, was secured by ADVISA, a company with a history dating back to 1901. Over time, the company evolved into the AZPI Group, diversifying its operations while maintaining a focus on railway expertise. With a century of experience behind it, the ASPI Group achieved remarkable growth in internal management, economic profitability, and international expansion. The construction of the CONTRERAS Reservoir Viar Gordo del Cabriel section began with the Ala de la Roda tunnel spanning 2,000 meters. This was followed by the Cuesta Negra viaduct, crossing a deep ravine, and a 100-meter excavation. However, the standout structure in this segment is the CONTRERAS Reservoir Viaduct, stretching 587 meters. Environmental considerations were integral to the project. The construction schedules were tailored to bird nesting periods in the park, and instrumentation was set up along the A3 highway to detect and prevent interferences. Complementary works included the construction of an overpass, a wildlife crossing, and a screen wall for highway support piles. Environmental integration work encompassed restoration, planting, hydroseeding, and reforestation, all meticulously designed to blend with the natural surroundings. On September 23, 2009, HAZBI successfully completed the project within the prescribed timeline, adhering to exceptional quality and safety standards. The CONTRERAS Reservoir High Lifting Speed project not only marked a triumph in engineering, but also highlighted the delicate balance between technological advancement and environmental preservation. ADIF's endeavors exemplify the power of human ingenuity and collaboration in reshaping the landscape of transportation infrastructure.
The Genoa-San Giorgio Bridge, also known as the Viadotto Genova-San Giorgio, stands as a remarkable motorway viaduct spanning the Polsevera River and the districts of Sampierdarena and Cornigliano within the city of Genoa, Italy. This impressive structure is the brainchild of renowned architect Renzo Piano. The bridge holds significance not only for its architectural and engineering prowess, but also for its role in replacing the ill-fated Ponte Morandi, Polsevera Viaduct, which suffered partial collapse on August 14, 2018, leading to its eventual demolition in June 2019. The inauguration of the new Genoa-San Giorgio Bridge took place on August 3, 2020, marking a significant milestone in the city's history. The design of the bridge was meticulously crafted by Renzo Piano through his building workshop. The official unveiling occurred on September 7, 2018. In the presence of notable figures, including the president of Liguria, Giovanni Toti, the mayor of Genoa, Marco Bucci, and the CEOs of Autostrade per l'Italia and Fincantieri, Giovanni Castellucci and Giuseppe Bono, respectively. The bridge's design comprises 4 lanes for vehicular traffic and 2 emergency lanes to ensure safety. The engineering marvel spans a length of 1,067 meters, approximately 3,501 feet, and is characterized by 19 spans held aloft by 18 reinforced concrete supports with an elliptical cross-section, maintaining a consistent shape throughout its expanse. Constructed using a blend of steel and concrete, the bridge was designed not only for functionality, but also for aesthetic appeal. One fascinating aspect of the Genoa-San Giorgio Bridge's maintenance strategy involved the deployment of robots designed by the Istituto Italiano di Tecnologia. These robots were equipped with wheels, allowing them to traverse the external rails of the bridge. Their tasks ranged from inspecting the underside of the bridge to cleaning wind-proof barriers and solar panels, contributing to the structure's longevity and efficiency. The construction of the bridge was a collaborative effort undertaken by companies Cellini Impregilo and Fincantieri, awarded the contract on December 18, 2018. This ambitious endeavor came with a price tag of €202 million, and its execution was achieved within a year thanks to the coordinated efforts of various entities. Notably, the RENA certification company oversaw the direction, supervision, demolition, and construction of the new bridge.
The 36-hour road bridge demolition and replacement project near Romsey in Hampshire marked a significant engineering feat involving intricate planning, cutting-edge equipment, and seamless execution. The endeavor aimed to replace an aging road bridge with a modern, structurally advanced one to ensure the safety and efficiency of local transportation networks. The execution of this ambitious project required the rental of an Ainscough crane, renowned for its remarkable lifting capacity of 1,250 tons. Months of meticulous planning were invested to ensure the success of the demolition and replacement process. Engineers and project managers collaborated to develop a comprehensive blueprint, taking into account factors like traffic diversion, environmental impact, safety protocols, and engineering requirements. Thorough assessments of the old bridge's condition guided decisions on the most efficient demolition approach. The demolition phase kicked off with the careful dismantling of the old bridge. This process involved removing various components, including the road deck, support beams, and any associated structures. Specialized cutting equipment and demolition machinery were deployed to systematically deconstruct the bridge while minimizing disruption to nearby traffic and the surrounding environment. Central to the successful execution of the project was the deployment of an Ainscough crane with an impressive lifting capacity of 1,250 tons. This high-capacity crane was chosen for its ability to handle the massive loads involved in bridge construction. The crane was positioned strategically to ensure optimal access to the construction site and to facilitate the precise positioning of heavy components during the replacement phase. The replacement bridge, which had been prefabricated off-site to expedite the process, was transported to the construction site in carefully coordinated stages. The Ainscough crane played a pivotal role in lifting and placing the new bridge components, including massive support beams and the road deck itself. The crane's precision control mechanisms allowed for millimeter-accurate placement of these colossal elements, ensuring the structural integrity of the new bridge. The 36-hour timeline for the project was a testament to the efficiency and expertise of the engineering and construction teams. Strict safety measures were implemented throughout the demolition and construction phases to safeguard workers, nearby residents, and the environment. The Ainscough crane's advanced safety features and experienced crane operators contributed to a smooth and accident-free operation. The successful demolition and replacement of the road bridge brought about substantial benefits to the local community. The upgraded bridge improved traffic flow, reduced congestion, and enhanced overall road safety. Additionally, the project demonstrated the advancements in construction technology and engineering capabilities, underscoring the potential for similar undertakings in the future. The 36-hour road bridge demolition and replacement project near Romsey in Hampshire showcased the culmination of meticulous planning, cutting-edge equipment, and expert execution. The deployment of an Ainscough crane with a lifting capacity of 1,250 tons played a pivotal role in achieving the project's goals within the designated timeframe. This remarkable achievement stands as a testament to the remarkable progress in modern construction and engineering practices. Switzerland, renowned for its precision and innovation, boasts the Gubrist Tunnel as a testament to its prowess in infrastructure development. Situated north of Zurich, the Gubrist Tunnel stands as a pivotal component of Swiss transportation infrastructure, exemplifying meticulous planning, cutting-edge technology, and skilled execution. Stretching across a distance of 3 kilometers, the Gubrist Tunnel, with its 2 lanes, holds the responsibility of mitigating a significant portion, 25% to be precise, of traffic congestion hours on Swiss highways. In a country where efficiency is paramount, this tunnel's expansion from its original state to a grand total of 7 lanes marked a remarkable feat. This ambitious endeavor, executed between 2019 and 2020, stands as the crowning jewel among Swiss infrastructure projects. Supervised by the Federal Roads Office, the construction of this new tunnel was entrusted to Marti AG, a company known for its expertise in the realm of civil engineering and construction. The tunnel's impressive width of 14 meters accommodates utility conduits and drainage canals within its lower section. The lateral spaces of the tunnel were judiciously filled with the excavation material, ensuring structural integrity while minimizing waste. A testament to precision and attention to detail, the construction process saw the tunnel gradually taking shape. After meticulous work on the road shoulders, the tunnel stood ready for the installation of the roadway itself. The road was meticulously constructed in several layers to ensure longevity and performance. The foundation was laid with 2 layers of gravel, a foundation layer followed by a sub-base layer. Above this sturdy base, 4 layers of asphalt were meticulously placed: an 8-centimeter thick base layer, a 3-centimeter thick binder layer, and finally, a 3-centimeter thick surface layer. What sets the Gubrist tunnel apart is the gradual improvement in the quality of its asphalt layers as they ascend. The foundational layers provide a stable and level base for the intricate road system. Ensuring accuracy in this process, cutting-edge equipment, including a 3D model of the road, was employed, allowing for precision within a margin of just 25 centimeters. This amalgamation of technology and expertise assured that the tunnel's construction adhered to the highest standards of quality. Assuring the quality and durability of the asphalt layers was a paramount concern. Rigorous testing followed the compaction of the layers. These tests consistently revealed results that outperformed the required standards by an impressive average of 30%. This stringent quality control process guaranteed that the Gubrist Tunnel's road would stand the test of time and continue to provide a smooth passage for generations to come. The process of laying the asphalt involved a symphony of coordination and machinery. The orchestration included a feeder and an asphalt paver, boasting a collective capacity of 45 tons. This extensive capacity proved invaluable in managing the challenges posed by truck changes and irregular deliveries. The feeder, an ingenious addition, ensured uninterrupted asphalt conveyance through a non-contact conveyor belt, thus promoting thorough mixing of the material. Central to the tunnel's flawless execution was the asphalt paver, a marvel of engineering that maintained the precision and alignment of the asphalt layer. Guided by distance sensors, this robotic marvel ensured that the asphalt was uniformly centered within the tunnel. The meticulous leveling, accurate down to the millimeter, was orchestrated by infrared sensors stationed at the paver's edges. An additional layer of quality control came in the form of continuous temperature monitoring. Thermal imaging cameras installed on the paver ensured that the asphalt's temperature met the desired criteria, an essential factor in ensuring long-lasting quality. Compaction, a critical element in ensuring the road's performance, was a process of finesse. The asphalt paver achieved an initial compaction rate of 85%. Following in its wake were tandem rollers, gradually increasing the compaction rate to a robust 100%. This meticulous process was fundamental to the road's longevity and its ability to withstand the constant onslaught of traffic. The Gubrist Tunnel project was nothing short of a ballet of engineering, spanning a total of 18 nights of tireless work. Within this time frame, a staggering 38 centimeters of asphalt layers were installed with precision and care. The culmination of this meticulously orchestrated endeavor came in the form of a final 3-centimeter wearing course, a delicate operation that was masterfully executed in a mere 2 nights. November 2021 marked the triumphant conclusion of the Gubrist Tunnel project. Meticulous planning, sophisticated technology, and the skilled hands of dedicated professionals melded together to create a masterpiece of engineering excellence. The tunnel stands as a testament to Switzerland's commitment to seamless transportation and a brighter, more efficient future. As the traffic flows smoothly through the tunnel's meticulously laid asphalt, it is a reminder of the extraordinary achievements that can be realized when vision and precision converge.
A vessel dedicated to the installation of offshore wind power plants, required the LR 13000's expertise to affix 4 substantial platform legs, each leg towering at 87 meters and weighing a staggering 920 tons, demanded not just power but finesse in handling. The LR 13000, equipped with a specialized power boom, extended its reach to a phenomenal 132 meters, showcasing its adaptability for such complex operations. What makes the LR 13000 stand out among its peers is its unrivaled might. It proudly boasts the title of the most powerful conventional crawler crane globally, a distinction earned through its remarkable utility in diverse settings, from power plant constructions to the erection of industrial columns in refineries. This behemoth consistently tackles the hoisting of extreme weights, setting new benchmarks in the industry. The crane's capabilities are nothing short of awe-inspiring. It shoulders the immense burden of industrial columns, weighing a mind-boggling 1,500 tons and stretching up to 100 meters in length. Despite its colossal size and lifting prowess, it manages to be transported across the globe at relatively low costs, an impressive feat in itself. What's truly remarkable about the LR13000 is its versatility. Unlike others in its class, this crawler crane doesn't always necessitate derrick ballast for operation, thanks to an ingeniously designed in-house manufactured slewing ring. This innovation endows it with unparalleled lifting capacity, showcasing the cutting-edge engineering prowess and forward-thinking approach of Liebherr. The specifications of the LR13000 are nothing short of extraordinary. With a maximum load capacity of a whopping 3,000 tons, a towering hoist height of 236 meters, and an expansive reach of 200 meters, it stands tall as a testament to human ingenuity and technological advancement. In the case of the Aeolus project in Bremerhaven, the LR13000 proved its mettle once again. Amidst the complex choreography of lifting and positioning the colossal platform legs onto the vessel, it demonstrated not just power, but precision engineering at its finest. The successful completion of this task underlines the reliability and efficiency of the LR13000, solidifying its position as an irreplaceable asset in the realm of heavy lifting and construction. Nestled within the rugged terrain of the West Hunan province in central China, the Aise Suspension Bridge stands as a testament to modern engineering prowess and architectural ingenuity. Constructed as a pivotal component of the Jishou to Chading Expressway, this bridge serves a crucial role in transforming the transportation landscape between Hunan and Chongqing, optimizing connectivity and enhancing the flow of traffic through the region. The bridge, unveiled to the world upon its completion in 2012, immediately captured global attention for its remarkable features. Its designation as the highest tunnel-to-tunnel bridge on the planet underscores its monumental stature, soaring an awe-inspiring 355 meters, 1,165 feet, above the breathtaking expanse of the Dahang Canyon. Crafted against the backdrop of the region's undulating topography, the Aise Suspension Bridge's design embodies both elegance and structural resilience. Its sleek, sweeping lines harmonize with the surrounding landscape, while the intricate engineering marvel hidden within its framework ensures unwavering stability and safety for all who traverse its spans. The engineering prowess involved in erecting this monumental structure is nothing short of remarkable. The construction process itself was a feat of coordination and precision, involving intricate cable-stayed technology and the assembly of massive steel cables that form the backbone of its support system. The bridge's deck stretches an impressive length, providing a vital passage for vehicles, linking distant regions and significantly reducing travel times between the provinces. Moreover, the HCONTROL Bridge has not only redefined the physical landscape, but has also become a symbol of progress and connectivity for the local communities. Its presence has catalyzed economic development, facilitating trade and commerce between regions that were once separated by challenging terrain. The bridge's impact extends beyond its utilitarian function. It has become an icon of architectural achievement, drawing tourists and admirers from around the globe who flock to witness its grandeur and marvel at the sheer audacity of human innovation.
The assembly process of the viaduct over the Favara River in Gunt involves the use of a beam launcher, which is a specialized piece of equipment designed to efficiently and accurately position girders during construction. To begin the assembly, the first girder is carefully aligned with the supports of the viaduct. The girder is then inserted into a rail or sliding mechanism that has been specifically designed to facilitate its movement. This rail serves as a guide for the girder as it is pushed into position. Once the girder is resting securely on the first support and guided by the rail, the actual installation process begins. The crane, equipped with a lifting boom, approaches the girder. The crane operator selects the appropriate attachment point on the girder, typically using a hook or clamp, ensuring that it has sufficient load capacity to lift and support the girder. The crane then gradually raises the girder, carefully lifting it off the ground or support structure. The crane operator and the assembly crew work together to ensure the girder remains stable and properly aligned during the lifting process. As the girder is raised, it slides along the rail, guided by the beam launcher. This gradual movement allows the girder to be positioned accurately and safely towards the second support of the viaduct. Once the girder reaches its designated position on the second support, the crane carefully lowers it into place. The assembly crew ensures that the girder fits securely onto the supports, forming a stable connection. This process is repeated for the remaining girders of the viaduct until all three girders are successfully placed into their designated positions. The viaduct over the Favara River is a hyperstatic viaduct with 5 spans measuring 45-60-60-60-60-45 meters in length. It is designed to accommodate a dual carriageway and reaches a maximum height of 60 meters. The precise assembly of the girders using the beam launcher is crucial to ensure the structural integrity and stability of the viaduct, meeting the necessary design specifications for safety and functionality. In Mill Creek Township, as part of a comprehensive project aimed at improving safety and traffic flow on Millfair Road, the construction of a bridge over the Norfolk Southern Railroad tracks was underway. The same project also involved the construction of another bridge over the CSX railroad tracks, both of which were designed to eliminate the existing at-grade crossings. To successfully install the concrete beams for the bridge over the Norfolk Southern Railroad tracks, a team from Chivers Construction Co., based in Erie, Pennsylvania, relied on the expertise of Giorgio. The intricate operation required the precise placement of 4 30-ton concrete beams, each measuring 114 feet in length. The beams had to be positioned accurately along a pre-drawn line on the bridge support pad. To accomplish this task, Giorgio deployed 2 cranes, which worked in tandem. These cranes were operated with great skill and precision, ensuring that the beams were lowered onto the bridge support pad with utmost accuracy. The installation of the bridge beams necessitated a temporary closure of Millfair Road. The closure allowed the construction crew to maneuver the cranes into position and execute the precise placement of the beams. This phase of the project was crucial in facilitating the safe passage of vehicles and pedestrians over the railroad tracks. The entire project, which encompasses the construction of both bridges, is estimated to cost $12.5 million. It is expected to span a duration of 2 years and covers the section of Millfair Road between its intersections with Route 20 and Route 5. Once completed, the bridges will enhance traffic safety and flow in the area, eliminating the need for at-grade crossings and reducing the risk of accidents. Utilize their LTM July 1, 1400 crane to install 4 bridge beams over live railroad tracks. These beams, weighing an impressive 117,500 pounds each and measuring 117 feet in length, presented a significant challenge due to the site's restrictions and ongoing train traffic. Due to the limitations of the site, all lifting operations had to be executed from a single side of the bridge. The team meticulously coordinated their efforts to ensure the safe and precise placement of the beams while adhering to a tight schedule dictated by the passing trains.
In 2013, Turkey included straw panel production in its investment plan, and by 2015, straw panel production had started in the Gaziantep industrial zone. Straw panel boards are ecological diffusional construction panels. Manufactured from 100% natural materials, straw-made panels are free from binding agents, and they are pressed under high temperature and high pressure with recyclable Edison. Straw panel boards are 100% natural, completely recyclable building materials that are appropriate to be the permanent parts of the construction. Straw panel boards have 2 options of 40 and 60 mm thickness, but for now, they can solely be prepared in 60 mm with a 1500 mm standard width, and at required ranges between 1,500 to 3,200 mm. Straw panel boards present the opportunity to order in required lengths, regardless of defects, easy and fast installation. Straw panel boards have the highest mechanics durability amongst its class. Another test performed on the wheat straw panels regarding resistance proves one more of its advantages against other materials, such as gypsum plaster. Another test performed on the wheat straw panels regarding resistance proves one more of its advantages against other materials, such as gypsum plaster. Straw panel boards hold all the necessary features for the construction of natural, healthy, and ecological houses without any harm on nature. Compact compress with straw ensures both the heat insulation over the average and the heat accumulation. Thus, the average night and day temperature difference realizes as 4 degrees, which provides savings on heating costs in general. Straw has the ability to insulate the sound when a street noise is around 60 decibels. An eco panel made simple wall without any surface coating would have a sound insulation of 33 decibels. Since the boards are made of compressed wheat straws and have no space left for airflow between fibers that could ease the burn, straw panel boards act as a barrier during the fire and don't allow the flame to spread. In the presence of 45 minutes long fire, 40 centigrade sub-needs can be felt on the other surface of the straw panel board. However, the flame can't pass through the board. The spire retardant effect is the biggest of its advantages. Ecological class straw panel boards are real and environmentally friendly materials produced from wheat strokes. Nowadays, the most important need for modern houses is the usage of eco-friendly natural materials that create healthy environments for the consumers. The fusional boards, which directly meet these needs, prevent the creation of tend and generation of more. Straw panel boards have a wide variety of usage, including new buildings, reconstructions, extensions, and loft conversions into rooms. This universal panel system can be used for self-supporting partition walls, soft pits, ceilings, interior and exterior wall right. While the panel system ensures the rapid construction of wooden buildings and facilitates the installation of boards, it assures precise and high-quality construction. By using low-costing straw panel boards, one can have a house at an affordable price and execute easy and rapid construction. The heating and cooling cost of straw panel board houses will be 40% less than the houses constructed with other materials. The biggest advantage of using straw panel boards in a house is to have self-sufficiency and low energy consumption compared to other buildings. EcoPanel can never sacrifice from its integrity and quality. If you want to save on heating, quickly and easily construct your building, and live in a healthy environment, straw panel boards are the ideal solution for you. Straw panel boards are a revolutionary construction material that meets the needs of modern housing. They are ecological, diffusional, and made of 100% natural materials. The high mechanical durability of straw panel boards makes them ideal for use in construction projects. The excellent insulation properties of straw by using low-costing straw panel boards, consumers can have a house at an affordable price with easy and rapid construction. The heating and cooling cost of a straw panel board house will be 40% less than the houses constructed with other materials. The biggest advantage of a straw panel board used house will be to have self-sufficiency and low energy consumption compared to other buildings. If consumers want to save on heating, they can quickly and easily construct their building using straw panel boards and live in a healthy environment. Straw panel boards are the ideal solution for consumers looking for eco-friendly, affordable, and easy-to-install construction materials.
Begin by cutting the HCONTROL hybrid strips to the required length, ensuring there's an overhang of at least 5 centimeters at each end. The embossed cold color film should be facing the inside or warm side of your building to maximize insulation effectiveness. Staple the insulation to the rafters every 100 millimeters to keep it taut and in place. Additionally, staple the 2 returns of the insulation to the rafters. Staple the insulation every 50 millimeters around the perimeter of the roof to ensure it remains secure. When you have to overlap insulation, make sure it extends 50 to 100 millimeters astride the intermediate support of the rafter. Pull the insulation taut and staple the overlap every 50 millimeters to create an airtight seal. Ensure that the installation is airtight by using ISO-TIS's reflective tape. This tape helps in sealing any gaps and making the installation more energy efficient. Secure the product to the purlins with a timber batten. Trim any excess insulation that extends beyond the batten for a neat finish. Maintain an air gap of at least 20 millimeters to allow the insulation to perform correctly. This gap helps prevent condensation and moisture issues. When insulating around windows, cut the product using an Actus cutter. Fold the product as needed and staple it to the structure with a batten. This ensures airtightness around the window area. For further airtightness and to secure the product around windows and other structures, fix a counter batten in place. One of the standout features of the AUSA X1100RH is its ability to load up to 1.1 cubic meters of materials in a single cycle. This substantial loading capacity significantly reduces the time and labor required for concrete mixing, making it an ideal choice for construction projects of various scales. It can easily load cement, stone, and sand, offering flexibility in material selection. Mixing concrete is a breeze, taking just a few minutes for each load. This rapid mixing capability not only speeds up the construction process, but also ensures the consistency and quality of the concrete mixture. This is a critical factor in ensuring the structural integrity and longevity of the finished construction. With its 1.1 cubic meter capacity per load, this self-loading concrete mixer minimizes downtime, increases productivity, and reduces labor costs. Furthermore, the X1100's self-loading feature eliminates the need for additional equipment or manual labor, saving valuable resources on the job site. The process begins with the installation of a packer. Packers are specialized fittings that are inserted into the crack or joint. They create a sealed space through which injection material can be introduced. The proper placement of packers is crucial to ensure that the injection material reaches the targeted area effectively. The next step involves preparing the crack or joint for injection. This preparation varies based on the nature of the crack or joint. In some cases, the area may need to be cleaned and cleared of debris or moisture to ensure optimal adhesion of the injection material. The actual injection process involves the compression of the crack or joint using specialized materials such as injection resins. These materials are introduced into the packer and systematically injected into the crack. The injection is typically done in multiple phases, ensuring the entire crack or joint is filled. This step is vital for sealing the crack and restoring the structural integrity of the concrete. Once the injection process is complete, it is essential to clean the injection press and any tools used during the process. Proper cleaning helps maintain the integrity of the equipment for future use and ensures its longevity. The final step involves cosmetic refinishing. This step is essential for both aesthetic and functional reasons. It ensures that the treated surface appears uniform and blends with the surrounding concrete. The process begins with the JCB3CX Backhoe Loader. Its front-end loader attachment is used to collect the necessary raw materials, which typically include sand, gravel, cement, and water. These materials are crucial for concrete production. Once the raw materials are gathered, the JCB3CX is equipped with the RAF MZB 600 mixing bucket attachment. This attachment is specifically designed for concrete mixing. The MZB 600 is mounted to the loader's front end and secured in place. It is equipped with a powerful mixing mechanism and a sizable mixing drum. The loader's front bucket is used to deposit the collected raw materials into the mixing bucket. These materials are carefully measured and loaded in the right proportions to ensure the correct concrete mix. With the raw materials in the mixing bucket, the MZB 600 goes to work. It starts mixing the ingredients thoroughly, ensuring that the concrete mix is of the desired consistency and quality. The mixing process can be controlled by the equipment operator, allowing them to adjust variables such as mixing time and water content for the best results. As the MZB 600 completes the mixing process, the finished concrete is ready for use. The loader's front bucket can then be employed to transport the freshly mixed concrete to the construction site where it is needed. This on-site concrete production eliminates the need for the transportation of pre-mixed concrete, reducing the risk of material segregation and ensuring the quality of the concrete is maintained. One of the key advantages of this combination is its versatility. The JCB3CX, with its multiple attachments, can seamlessly transition from raw material collection to concrete mixing and transport, making it a highly efficient solution for construction projects.